Alright, next one we have to solve z cubed excuse me, plus I equals 0 for all z. Now you can see straight away that you won't have any conjugate pairs in here because of the I. To kickstart this, we have to find a solution, and the way to do that is simply say, well, I can see that by putting in an I there, let's do that. Z equals I, then I cubed is going to give me minus I, and of course that will give me 0. So Z equals I is a solution. Now, having done that, we could just equally space them around the circle and get a result, but just assume that we don't know that, and we'll just divide this by the factor Z minus I. So I'll put Z minus I into Z cubed plus I, and now we'll have a Z squared there, and a Z cubed minus I Z squared. Now I'll subtract that, it becomes I Z squared, bring it down, plus I. Now I'll multiply that by I Z. I get my I Z squared, and here I'm going to get just a Z. Okay, now subtract. I get a minus Z plus I, and now I need a minus 1 here, which gives me a minus Z plus I, and there we have it. So Z, factorizing this one, not factorizing, solving this one, Z is equal to minus I plus or minus the square root of minus 1 plus 4 all over 2, which becomes minus I on 2 plus or minus root 3 on 2. So the solution. You see, this is not coming in conjugate pairs, because we should really rearrange it the other way. See, it's plus or minus root 3 on 2 minus I on 2. That's not a conjugate. Well, it looks like it could be, doesn't it? All right, now what we'll do next is do the faster technique. Right, now in part 2 we have to solve z cubed minus I equals 0 for all z. Now we can see here that z equals minus I is a solution. Just checking that out, that's minus I cubed, which is minus 1 cubed times I cubed, which is minus 1 times minus I, which is just I, and I minus I is 0, so that's a solution. Now we're not going to use long division, because we'll just simply say that we know it's going to be equally spaced around the unit circle. So we'll just start off with minus I down here, that's your minus I here, and we'll go back to pi upon 3 here, ending up at pi upon 6, and on that side there that'll be pi upon 6 this way, but 5 pi upon 6 that way. So our solutions are Z1 was equal to, this will be the cis of minus pi upon 2, Z2 is the cis of pi upon 6, and Z3 equals the cis of 5 pi upon 6. And I'll leave you to convert that to the Cartesian form if you want to, but that's the correct solutions in the polar form.